In this video, we'll showcase 3 tricks for debugging networking on Google Cloud. We'll spend about a minute describing these 3 tricks, and then we'll spend the rest of the video demonstrating them in Google Cloud Console. I'll also note that these are outside of the standard packet mirroring and cloud operations type services that serve as the foundation for network visibility. The first trick is the connectivity test service that's available in the Google Cloud Console. This gives us a console-based GUI approach for testing connections across VMs, services, or endpoints. In these connectivity tests, we'll see exactly where we may have misconfigured routing, or perhaps where we may be unexpectedly hitting firewall deny rules. The next trick is the Google Cloud Shell. This is really nice for running standard networking utilities and CLIs such as curl or dig, but from an environment that's not your local laptop. Local IDEs and terminals can have limitations, and the Cloud Shell gives us another vantage point from which to run network testing. The final trick that we'll look at is the HTTP/HTTPS Echo project. When we set up this open source service on something like Cloud Run, we can use it as a backend that echoes HTTP request properties back to us. This can be particularly useful for things like load balancer rewrites. For example, maybe we put a load balancer in front of the Cloud Run service and then hit the load balancer and see a response that captures what the Cloud Run backend is actually seeing. All right, so let's jump right into the console and see these in action. We'll actually work in reverse order, starting with Cloud Run. So, in the console, let's open up Cloud Run and then create a service. We'll use the open source HTTP/HTTPS Echo project via the images published to Docker Hub. We'll also link the project's GitHub repository in the description of this video so you can check it out. We'll use port 8080 for the service and provide a couple environment variables that explicitly define HTTP and HTTPS ports. And it looks like we need to specify the authentication, so we'll choose Require Authentication. All the other defaults are fine, so let's proceed. We have our service up now, but if we go to the service in the browser, we'll of course get a forbidden error. That's expected, since we didn't make this service public. Blurring the lines between our first trick and the next, let's open up our Cloud Shell, leverage its seamless authentication, and access the Cloud Run service with the curl command. So, with our Cloud Shell open here, let's hit this Cloud Run endpoint and supply the required bearer token. Our Cloud Run endpoint is the URL at the end here. When prompted, we'll click to authorize. This test would probably take longer on a local laptop, and in any case, the shell is nice as a secondary source of networking tests. Because we're using the HTTP/HTTPS Echo project, the response that we're getting back from this curl command has tons of insightful request details. For example, we see things like the request headers, query parameters, protocol, and host name. When you're hitting an endpoint directly, you can have control over the request, but in a more distributed or multi-hop setup, this sort of request detail can be very helpful. Alrighty, let's wrap up with looking at the connectivity test service. Imagine, for example, that we wanted to test HTTP connections from our Cloud Run service to the public internet. This destination is an IP for example.com, and we'll test on port 80 to simulate HTTP traffic. When we create that network test, we'll see that the IP is indeed reachable. If we have issues with, for example, firewalls or routing, we'll see the specific rules and details here. We're showing a very simple example, but again, more complicated enterprise networking can make debugging a failed connection very challenging. Is it the client, the firewall, the routing, the API scopes, the server, the service, or something else entirely? The connectivity test gives us deep insight into the answer. And that's it. We hope you find these tricks valuable in your Google Cloud networking analysis. We'll keep an eye on the comments for any questions, and thank you for watching.